In the silence between worlds, there is a moment that defines every journey beyond Earth. Not the launch, where power overcomes gravity. Not the voyage, where distance becomes memory. But the return, a passage where speed turns into fire, where the thin line between physics and survival is tested to its limits. For decades, humanity has learned that coming home is the most unforgiving part of the journey, because space does not resist you, but Earth does. This is the story of what it takes to come back. After a journey of nearly 700,000 kilometers, the Artemis II mission faced its final and most violent challenge, re-entering Earth's atmosphere. But coming back has always been harder than leaving. All the energy built up during the mission had to be released in just a few minutes, equivalent to thousands of kilograms of explosives. The first step of the return was a critical separation. The European service module, which had provided power and propulsion throughout the mission, was jettisoned to burn up in the atmosphere. Now alone, the crew capsule, named Integrity, had to orient itself with absolute precision. Its small thrusters fired to align the heat shield perfectly with the direction of travel. A deviation of just a few degrees would have meant disaster. Too steep, and the capsule would turn into a fireball. Too shallow, and it would skip off the atmosphere, lost in space forever. At an altitude of 122 kilometers, it reached the entry interface. Its speed was nearly 40,000 kilometers per hour, about 11 kilometers per second. And here lies one of engineering's most counterintuitive truths. The extreme heat of reentry does not come from friction, as many believe. The speed is so extreme that the air cannot move out of the way in time. Instead, it is violently compressed in front of the capsule, forming a shockwave. That compression generates temperatures of up to 3,000 degrees Celsius, hotter than volcanic lava, enough to melt steel in seconds. Yet the Orion capsule was not designed to resist this inferno. It was designed to pass through it. Its heat shield, nearly 5 meters in diameter, holds a brilliant secret. It is not meant to withstand the heat, but to sacrifice itself. This material, known as AVCOAT, is applied in blocks over a honeycomb-like structure. When exposed to extreme heat, it doesn't simply get hot, it transforms. The resin within it sublimates, turning directly from solid into gas. This process, called ablation, absorbs an enormous amount of energy. As the material breaks down and peels away, it carries heat with it, creating a layer of gas that pushes the plasma away from the capsule's surface. It is as if the shield sweats superheated gas, forming an invisible barrier that protects everything inside. Layer by layer, the shield chars and erodes, preventing the extreme heat from reaching the structure and the crew. During the most critical phase, the capsule was completely enveloped in blazing plasma. This ionized shell blocked all communications with Earth. For about 6 minutes, to mission control, Orion simply disappeared. Inside the capsule, the astronauts were pressed into their seats under forces of up to 4 times their body weight. Rather than diving straight down, the spacecraft used the atmosphere itself to slow down, skipping along its upper layers to spread the heat over time. Then, after the silence, came the moment everyone was waiting for. Communication was restored. The crew's voice broke through the static, confirming that the most dangerous phase was over. Even then, the capsule was still traveling at supersonic speed. At around 7 kilometers in altitude, a precise sequence began. A small controlled explosion ejected the forward bay cover, revealing the parachute compartment. 2 smaller parachutes, called drogues, were deployed. Their job was not to land the capsule, but to stabilize it and dramatically reduce its speed. This step was critical. Deploying the main parachutes too early would have torn them apart instantly. Once stabilized, the drogues were released, initiating the final phase. 3 pilot parachutes were deployed, pulling out the 3 massive main parachutes. At first, they appeared small, but they inflated in stages, a carefully controlled process to prevent excessive loads. Each one expanded to an area of over 1,000 square meters. Supporting more than 10 tons, they reduced the capsule's speed from hundreds of kilometers per hour to less than 30 seconds before impact. Final systems were prepared. Remaining fuel was vented, and the capsule aligned itself for ocean contact. The landing was designed to occur at an angle, using the resistance of the water to dissipate the remaining energy. After splashdown, one final system stood ready. If the capsule flipped over, inflatable bags would automatically deploy to restore it to an upright position. And so, from nearly 40,000 kilometers per hour to a controlled descent over the ocean, the combination of extreme physics and sacrificial engineering completed its mission. The heat shield, now a charred and scarred surface, remained as a silent witness to that passage through hell and to the safe return of humanity from another journey beyond Earth.
Thanks for watching. We are Exposed Engineering. Subscribe for more.